example was not that tough. Now, if we have talked about MOSFET and its normal working, and how to calculate the conductance, how to calculate capacitance, how to calculate drain current, how to calculate when there is a change in the manufacturing parameters. Not in the manufacturing, by the working we cannot change the manufacturing parameters, but yes, the other parameters such as the channel length modulation, which is because of the increase drain voltage. There is one more parameter, is the substrate bias parameter. That is the fourth point. Usually we take the substrate to be grounded, but if a voltage is applied at the substrate, then the effective threshold voltage changes. How that is being changed, let's look at that. In the reverse bias, the widened W depletion layer contains QD amount of charge. The QD amount of charge is given by this formula, minus under root 2 epsilon is QNE to phi F minus VB. The VT formula is VT of 0, that initial threshold voltage, plus gamma. What is gamma? Gamma, you can consider it to be a constant right now. Under root gamma in brackets under root of 2 phi F plus VB. VB is the substrate voltage and phi is the Fermi level, minus under root of phi. Now what was gamma? Gamma is a constant for under root of 2 epsilon SI Q and A by COS. Now epsilon SI is 11.7 into epsilon naught and phi F is a physical parameter. Okay. The source terminal is connected to the substrate or the body terminal in many applications. If the source and substrate are connected to ground, biasing of PN junction is 0. In such a case, substrate does not play any role in the circuit and its existence can be ignored. The substrate is usually connected to the most negative power supply in the PMOS. In such a scenario, source is connected to ground. P-type substrate is connected to the negative supply, resulting negative bias. This will have an effect on the device. The reverse bias voltage will increase the depletion region at PN junction. This in turn reduces the channel depth. Now, what we need to do is, we need to make the channel to its former state. We can say that, in other words, we can say that the threshold increase in NMOS. And it can be shown that increasing the reverse bias results in an increase in VT. According to this relationship, if VSB increases, VT increases and ID decreases. Therefore, we can say that the body voltage controls drain current. Thus, the body acts as another gate of MOSFET. This phenomenon is called the body effect. Temperature effect. The threshold voltage and the conductance parameter are temperature sensitive. The magnitude of VT decreases by about 2 mV for every 1 degree rise in temperature. The decrease in threshold voltage gives rise to the corresponding increase in drain current. However, the transconductance parameter decreases with temperature and its effect is dominant. The overall observed effect of a temperature increase is a decrease in drain current. Now let's look